had determined that it really is accurate to say that Leibniz had his just entire other system that was independent of Newton. He had a completely different notation. It's the notation which we have by and large adopted. So, okay. All right, cool? Cool. More. Flip it back up to the front. He was also, Leibniz, bothered by these infinitesimals, these infinitely small things. And as did some of the other people, he, like Kepler, he kept saying that, like, okay, look, I'm using infinitesimals because they're really, really easy and because I love them. If I really wanted to, I could do this properly using the method of the ancients, like Archimedes did, with some kind of terrible double reductio argument. But I don't want to because that would remove the power from calculus. Calculus is so powerful that you can't stop me from using it because I just love it. And he came up with all kinds of, in defense of his use of infinitesimals, he came up with all kinds of wishy-washy explanations, such as like, okay, you know, these little things, dx and dy, well, let me just assert as a general principle that if there's some ratio that's true when they're still not zero, then it will still be true when they are zero. And basically, okay, this is the same problem. No one knows what to do. He, when asked to defend infinitesimals, he disregarded. Oh yeah, he just kind of says, he just kind of like wants it both ways. He wishy-washy says, well, I'm not sure if infinitesimals actually exist or they are just kind of placeholders for something that really exists. He's just not sure. All right, as I mentioned, there's this priority dispute between Newton and Leibniz. It got so incredibly ugly. I forget the exact details of it, but essentially, England was separated somewhat, not just geographically, but linguistically, culturally from the rest of continental Europe. And Newton, because he's such a weird guy, he never published his papers. He kept them kind of a secret in a certain sense. And he did not really tell people his calculus. In fact, when he published his most groundbreaking work in physics, he actually hid the calculus. It was not in the physics. It was sort of like done, outside the work. And so you couldn't really go through and even follow what he was doing. He believed for 20 years that he was just the only one that knew this stuff. And in fact, he wrote all kinds of secret riddles and anagrams. He basically what's that called, ciphers and stuff like that. He converted many of his he sent Leibniz a letter in which the supposed key to understanding calculus, the fundamental theorem of calculus, was encoded in some kind of cipher in Latin or something like that. And when Leibniz comes out 15 years later with these big ideas of calculus, Newton says, well, of course you got it, because I sent you a letter in which the big idea of calculus was encoded in some kind of cipher, and you were supposed to learn that. Okay. Ultimately, Leibniz, being a more normal person, kind of wins out, and there's this a break between mathematics in England and mathematics in continental Europe, based on the people who follow Newton and those who follow Leibniz. And one of the reasons why in calculus we have so many frustratingly different notations is because we've retained to some extent Newton's notations and also Leibniz's notations. Yo.
But there are 4, not just...
Yeah, there's even more, yeah.
Why?
Yeah. Look, which ones?
Laplace,
the x dot is the one that is physics. Definitely Newtonian. Physicists still often use that because it's very nice, yeah. Yeah, okay, yeah. I mean, this just kept happening. All right, and what a big part of chapter 6, let's try to get to a good point, is of Klein, is that that certain people were very upset with this new kind of math, this new calculus. And in particular, what they were so upset about was these infinitesimals. What the hell are they? In particular, this guy, I think I'm supposed to pronounce his name, Berkeley, one of the most famous philosophers in England who, at this time period, had all kinds of crazy ideas. Very religious person. And I think the story goes something like his best friend, who was another famous person I can't remember, got converted to atheism by Leibniz. And Berkeley was so angry that he decided that he was going to attack calculus. And this person wrote a book saying how belief in God was just absurd and silly and ridiculous and making fun of anyone who believed in God. And Berkeley says, well, I am going to write a book making fun of calculus. And he basically writes this entire thing called, what's it called? It's something like Letter to an Infidel Mathematician or something like that, in which he attacks, quite coherently, all of the fundamental ideas of calculus as being basically incoherent. And these infinitely small quantities just sort of don't make any sense to him. The thing that they apparently found so incredibly weird was not just derivatives, but like second derivatives. They were like, okay, I'll let you have like an infinitely small thing, but like, if you take the derivative again of something that's already infinitely small, like, that's just absurd. I refuse to accept this. And so he's making fun of, to conceive a part of such infinitely small quantity that's just, okay, all right. What happens over the next 150 years is everybody tries to fix calculus. What does fix it mean? Fix it means figuring out what the hell infinitesimals are. And they are these infinitely small quantities, but unlike the glory past of Euclid, in which everything is laid out completely and totally clearly, calculus in fact has no foundations whatsoever. Not only is it not axiomatic, it's literally almost contradictory if you read it in a literal sense, right? There are these things, they're zero, they're not zero, they're zero, they're not zero, don't ask me too many questions about it, I don't know, it works, it's beautiful, give me my physics. And over the next 100 years, people keep trying, I don't even really want to talk, let's stop here with this slide. People are trying to fix this, it's sloppy. There are no proofs. To the extent that there are proofs, they're terrible. And basically, no one knows what to do about it. All right, cool? To be continued next class.